A midpoint is a point equidistant from two other points and is on the line segment connecting the 2 points. What I'm going to start with first is dissecting that definition. There's two key parts to it, and I want to make sure that both of those get addressed. Now, to do that, what I'm going to do is reference the picture that I have for example number 1. So a little bit later, we'll actually do the example. Right now, I'm just going to talk about it as it fits that definition. Okay, so a midpoint is a point that's equidistant from two other points. In this picture, that would be point C, okay? Point C is going to be equidistant from A to B. Equidistant means the same distance away, okay? So C, its distance to A is going to be the same distance that it would be to B. All right, the other part of the definition says that the point has to sit on the segment that connects the two endpoints, okay? A and B would be the endpoints here, and when you connect them, the midpoint has to sit on that segment. Now, that should seem like obvious when we think about the concept of midpoint being the point that sits between them. But if we leave the definition just with the concept of being equidistant, there's actually an infinite number of points that are equidistant from A to B. So what I'm going to try and do here is demonstrate that to you. What I don't want to do is draw on the picture, so you're just going to have to sort of imagine what I'm doing here. Okay, I'm going to take a ruler and set it up so that it's crossing the segment at the midpoint. And what I want to do is make sure that, or imagine at least that the ruler is at a perpendicular, that we have a 90-degree angle here. If we do that, then it ends up that any point that sits along that edge is actually going to be equidistant from the two endpoints. Okay, if I took any point that was out there and then I just connected it to the two endpoints, what you'd end up with is this symmetric triangle, an isosceles triangle. The distance from that point to each of those would be the same. Now, I could put a point even higher up, the same thing would still be true, that it would be equidistant from the endpoints, or I could put a point on the bottom, which would also be equidistant. So if we leave the definition at just a point that's equidistant from the other two, there's an infinite number of choices that would be, so you wouldn't exactly get the midpoint. But there's one point that when you actually connect A to B, there's only one point that's actually equidistant and sitting on that line. That would be the midpoint. Example number 1 is basically an algebra problem that's designed around the concept of midpoint. Okay, and as mentioned before, C is the midpoint to A and B. Let's talk a little bit about notation before I actually get into the algebra part of that one. Right here where we see this bar that's over the letters A and B, that's a symbol that actually indicates that we have a line segment, which is a line that has two endpoints on there. So the beginning part reads as, if C is a midpoint of line segment AB. So there's a segment that exists and then C is sitting in the middle of that. All right, now if C is sitting there, we want to find these three things, AC, CB, and AB. You're going to notice at the end here that you've got AB again, but it doesn't actually have the bar above it. Okay, so this is not line segment AB. This is line segment AB, and it's referring to the shape that we have, which is that line. When you just have AB, that is actually read as the distance between A and B. So all of these without the bars on them are referring to a distance, and what we're trying to do is figure out what that length would be. Okay, so altogether, this is how you could read it. If C is a midpoint of line segment AB, then find the distance from A to C, the distance from C to B, and the distance from A to B. Okay, now you don't technically have to read it like that, but that's exactly what it means. You can just say find AC, CB, and AB, but it's implied that it's the distance there. So the problem is going to begin with us taking these two expressions and then setting them equal to each other. So we've got 2x plus 1 is equal to 3x minus 4. Okay, now the type of equation that we have here, it does have x's on both sides of the equation. If you do have x's on both sides of the equation, what I suggest that you do is identify the one with the smaller coefficient, that would be the 2 versus the 3, and go ahead and subtract that part from both sides of the equations. So I'm going to subtract 2x from both sides. When I do that, these two x's are going to cancel. Basically, they subtract each other out, so they're gone, and all you're left with is the 1. Okay, on the other side, when you subtract the 2x, I should say subtract, When you subtract the 2x from the 3x, you're going to be left with a single x, well, that's 1x. And then we still have the minus 4. At this point, we have all of our x's on one side of the equation. Once you have all the x's on one side of the equation, then what you're going to do is just move anything over that happens to be on that side of the equation. In this case, that would be the minus 4. So what we'll do is go ahead and just add 4 to both sides of the equation. I don't quite have room right here, so I'll just jot it over to the side. When you do add the 4 to the 1, they're going to cancel on this side, actually. When you add the 4 to the 1, you're going to get 5, so we end up with x is equal to 5. Okay, so to complete the rest of the problem, what we're going to do is take that value of 5 and we're going to plug it into the expressions that we have. So if I plug it into the first, we're going to multiply 2 times 5, which is going to give you 10, and then 10 plus 1 gives you 11. So AC is going to be 11. CB should be the same length. It should also end up being 11, but we'll go ahead and plug it in just to see that that happens. When you plug the 5 in, you're going to get 3 times 5, which is 15, and then 15 minus 4, in fact, is 11. So everything seems to be working well. AB, which is the distance completely across this whole thing, you don't need to plug the 5 in because that'll just be redundant to all the work, but we can just go ahead and add the 11s together or do 11 times 2, which will give you 22. All right, in example number 2, we're going to plot a couple of points A and B in the coordinate system. That would be the XY coordinate system. And we're going to identify where the midpoint would be between those 2 points. But the real purpose of the question is to actually lay a foundation so we can figure out a formula for finding the midpoint between any 2 coordinates. So we're going to do like a sample problem. We're going to look at the answer, and then we're going to start to look at the answer that we got based on the coordinates that we had and hopefully develop a formula that can be used for other problems. Okay, so we're going to go ahead and start by plotting the 2 points that we have here. Point A is at -4, 2, so that means you're going to go to the left 4 units and up 2 units. Point B is at 210, so that's going to go to the right 2 units and then up 10 units. Okay, so that's point A, that's point B. All right, and as it was defined earlier, midpoint will be the point that's equidistant from those 2, but also sits on the segment that connects them. So what I'm going to do is go ahead and connect these so that I can see that, that segment. Now, for the most part, because these 2 points are pretty close together with each other, you can probably eyeball where the midpoint is. In fact, if I start to narrow it down, I'm going to feel like it's about that area. Okay, and if I were to actually choose a coordinate, I would go at this point. Okay, so I would consider that one being the midpoint. Now, is it actually the midpoint? Well, if it's equidistant from A and B, then it will be that midpoint. So now what I'm going to do is start looking from different perspectives. I'm going to look from the vertical perspective and then also the horizontal and see if it does sit in between them. So vertically, if you look from A to B, right, A had a height of a 2 and then B's got a height of a 10. Okay, so there's a space between those of 8 units. And if I divide that 8 units by 2, I'm going to get 4, right? Okay, so if I look at A to this point that I think is the midpoint, just count vertically 4 units. I go 1, 2, 3, 4. You can see that's in alignment with that point. And then if I continue on another 4 units, 1, 2, 3, 4, that gets me up to the height of B. So vertically appears to be the right coordinate. Horizontally is going to show us the same thing, except that the distance isn't going to be 4. You're going to go 1, 2, 3. That will get you lined up with what we expect to be the midpoint. And then if you go another 3 units, we'll just start from here. Go another 3 units over, 1, 2, 3. You can see that that gets you to B. So vertically and horizontally, it looks like that coordinate is actually directly between those 2 points. All right. In addition to just sort of eyeballing it there, what I want to do is show you one other thing. It's a neat idea with the fact that this is a midpoint and might give you some ideas on how you can think outside the box on stuff. So remember that the midpoint is equidistant from A to B. So that would tell us that the distance from the midpoint to A and the midpoint to B is the same thing. So what I'm going to do is take the paper, and this might be hard doing it with computer paper, because you can't quite see through it, but I'm going to attempt to fold this over so that I can get point B on top of A. And I'm actually going to look from the side here because it might be a little bit easier to match it up versus trying to look through the paper. Okay, but I believe that I got point B on top of A. And if I make a little crease right here, that is actually going to divide up that segment in half. Okay, and then we can see that the crease goes right through at that point. Okay, so another way of looking at midpoint based just on the definition, right? If we fold it in half, it's going to divide it at that center point. All right, so the answer, right? What is the midpoint? Here, let's call it point M. I think that would make the most sense in this problem here. Just call it M. All right, that coordinate from the origin, we got to go back 1 unit. So that means you got a -1. And it is going to be up 1, 2, 3, 4, 5, 6. It's going to be up 6. Okay, so the midpoint is at -1, 6. Now, really where we want to go with this, right, is that we should be able to give you any 2 coordinates and figure out where the midpoint is. These 2 coordinates work out a little bit easier because they're pretty close to each other, and you can really just like count boxes and figure out like exactly where that spot is. But what if you had coordinates that you couldn't easily apply? You know, they're 2 3-digit numbers, they might even be fractional numbers or decimal numbers, right? So things that might be more complicated. How can you actually just take the coordinates? How can you take those coordinates to figure out where the midpoint is? Okay, now the first key thing to figuring this out is to realize that when I went through the picture and I was trying to decide if that sounded right as a midpoint, I looked at the vertical completely separate from the horizontal. I didn't actually mix them. I let them be 2 individual ideas. So when we look at the 2 coordinates that we're provided here, each of those coordinates has an X and a Y value, right? So it has a horizontal and has a vertical component to it. The answer to the midpoint also is that. So somehow the -4, that X value, and the 2, which is the X value from the coordinate B, those 2 numbers should somehow produce the -1. Okay, and likewise, if you take the Y values, the 2 and the 10, those should produce a 6. Okay, now when you look at this, don't get confused here that it's that coordinate. This 2 is actually the Y value from A, and then the 10 is the Y value from B. Okay, so somehow those values should be able to create these numbers. So here's our question. What is a mathematical procedure for finding a number halfway between 2 other numbers? So I want you to consider that question. What is a mathematical procedure for finding a number halfway, midpoint is halfway between 2 other numbers? Then, if you can think of that procedure, apply it to these numbers and see that you actually get the coordinates for the midpoint. I hope that you came up with an answer to that question, something that you think works. I hope that you also tested it out and verifying that it did. Now, whether you came up with the idea or not, here it is. What I was thinking of was the average. If you take the average of 2 numbers, you're going to get the number that's halfway between those 2. So you can think of any examples you want and just consider, okay, what happens when I average them, and do I really get the number that's halfway between them? Okay, but let's take a look at the coordinates that we actually had. If I'm going to take the average of these 2 X values, what I would need to do is add them together. That's what averaging is. You add all your numbers and then you divide by the number of them you have. So I've only got 2 numbers. I'm going to add them together. Then I'm dividing by 2 because I had 2 numbers. Okay, -4 plus 2 is going to give you -2, and then -2 divided by 2 is going to give you -1, the number that we had for the midpoint. Likewise, for the Y values, we can take the 2 plus the 10, these 2 numbers here, divide that by 2. So when you add them together, you're going to get a 12. Then 12 divided by 2 is 6, which is our other component. So, as simple as I can describe it here, midpoint is average. It is the average of the x's, it's the average of the y values. This is your midpoint formula. Okay, what we have are two coordinates. One coordinate is going to be called x1, y1. The other one's called x2, y2. The subscripts, the ones and the two, all those do is identify which x's go with which y's. Okay, so x1 does go with y1. It just helps you keep everything organized. Aside from that, there's no mathematical thing going on with the subscripts. Okay, and then this is how you calculate midpoint. It just says take your x's, right, x1 and x2, add those together and divide by 2. Do the same thing with your y's. You're taking the average of them. And if you take the average of them, then you get your midpoint. Example number 3 is going to give us a chance to practice that concept of taking the average of the x's and the y's and identifying midpoints. Okay, so what you're provided with here are 3 coordinates. You got P, Q, and R. And we're going to find all the possible midpoints we have. Okay, now a midpoint is going to be that point that's between two other points. So really what we need to do is look at how many combinations of 2 coordinates can we get. You can get P with Q, that could be your segment. You could also do P with R, that would be a segment. Actually, let's space that out a little bit. And you can also do Q with R, that could be your other one. Okay, so overall we can get 3 segments, which means that we can get 3 midpoints. All right, so PQ, to figure out the midpoint, let's stick with the idea of just averaging, okay? So we can start with our x's. Actually, I don't want to do that yet. Okay, so start with our x's. From P, you've got -2 and you've got 4. So what we want to do is add those numbers together, which is going to give you a +2, right? 4 minus 2 is basically what that turns out to be. So you get 2, but you're going to have to divide it by 2 for the averaging. For the y values, you're going to take -3 and 5, which is going to add, oh, looking at the wrong there. You're going to take -3 and -7. Okay, -3 and -7 is going to give you -10. And that's going to get divided by 2. All right, so now when we divide them, we're going to get 1, and we're going to get -5. And that's the midpoint to PQ. All right, so for PR, looking at the x's, we got -2 and we got 0, so added together is -2. That'll get divided by 2. For the y values, we got -3 and 5, which is going to give you 2. That'll get divided by 2 as well. So now when we divide, we get -1 and 1. So that would be the midpoint of PR. For QR, we got 4 and 0, which would be 4 over 2. We have -7 and 5, which is going to be -2 over 2. We divide them, we're going to get 2 and -1. So that's the midpoint of QR. Example number 4 is more or less the challenge problem in the notes here. This you can think of as like a backwards problem. So in example number 3, you get 2 endpoints and you're asked to figure out where the midpoint is. You just need to average the x's and average the y's. But in example number 4, you're going to get 1 endpoint and you're going to get the midpoint. And what we need to do is track down what would have been the other endpoint to produce that midpoint. All right, now my approach to this question is not going to be based on averaging, which is what I do in all the evaluating problems for midpoint. What I'm going to do is instead go back to the definition and think about the concept of equidistant. Okay, so I'm going to start with just a picture of a segment. Okay, now the segment, I drew it as a flat line here. Okay, but in reality, if I were to graph the coordinates, this might be at some sort of a diagonal. Okay, so I'm aware from the beginning that this isn't going to fit how it would look on a grid, but it's still going to get the job done. Okay, so I'm going to put this endpoint here. Here's my midpoint. All right, and this is the mystery that we don't know. We don't know what the other endpoint is here. Now, of course, as I was trying to explain there a minute ago, it might not have made sense at that time. If I were to plot these coordinates, it doesn't make a horizontal line. It doesn't, right? It's going to look totally different, and this coordinate's actually going to be more to the left than the coordinate that we have here. But it's still going to work for what I want to do. So I'm going to base the idea on equidistant. And remember that in example number 2, I was counting boxes and showing that the horizontal space was the same to the left and the right, and the vertical space was the same on the bottom and the top side. So I'm going to separate my my x's and y's and just sort of investigate what we have here. Okay, so first I'm going to look at the two x's that they gave me. Okay, I got a 1 and a -6, and I'm going to ask, what's the space between those numbers? Like if I placed them on the number line, how far apart would they be? The answer to that is 7. Okay, now on a number line, they would be flipped. You'd have -6, which would take you to 0, and then one more would get you to 1. So you have a total space of 7. Okay, and it's kind of important to understand that like these numbers are actually backwards from how they would be graphed. So I'm going to add in one more part to this. I'm not just going to ask how far is it from 1 to -6, but I'm going to ask how do I get from 1 to -6? Okay, so the space is 7, but do I have to add on 7 or do I got to subtract it? And to get to -6, I need to subtract it. So really what that kind of tells me is from the endpoint to the midpoint, I actually got to go to the left 7 units, okay? But I can describe that as just saying subtract 7. And now, to get to the x value of the other endpoint, I can just continue the pattern. If I got to go left 7 to get to the midpoint, then I need to go left 7 again to get to the other end of the segment. And that's done by just subtracting. So I subtract 7 to get to -6, and then subtract another 7. It's just going to give me -13, and that's where the endpoint is located, at least as far as the x value. Now we do the same thing for the y values. We just ask, how do we get from 2 to 4? You add 2. Okay, so let's add 2 onto the midpoint. 4 plus 2 gives us 6, and that's the coordinate to the other endpoint. And in fact, you can even do a little bit of averaging if you want, right? To check your answer. You can take 2 and 6 and add them together, which gives you 8. 8 divided by 2 is 4. We can do the same things with the x. We can take 1 plus -13. That's going to give you -12. -12 divided by 2 is -6. And everything checks out.
Wait, what?